this video, I'm going to demonstrate how to call GP4 or gene product 4 of tBrady12. The materials you'll need to begin calling genes include the DNA master program installed into your computer, and it must be updated. Your preferences must be set in DNA master. And as you set the preferences, you need to make sure that the template in the notes sections contains this particular text, because this is your guide on how to take notes in DNA Master. So once you auto-annotate your genome, for each gene in the notes section, you should see this particular text. Of course, you also need a DNA master file of your phage genome, preferably with BLAST data. And you also need coding potential for the phage genome that you're annotating. If it's tBrady12, then you need both GeneMark S and GeneMark SMEG. SheerCon, also GeneMark S and GeneMark SMEG. And for QUIC, you might need tuberculosis coding potential. And finally, GeneMark Gordonia, GeneMark S, and GeneMark SMEG for Sally Special. So what we want you to do is to examine the example gene call below and the data presentation, but also look very closely at my notebook presentation for both GP4 of tBrady12 and also a second gene, GP42, which is a reverse gene. And the call for that is more or less the same with some very slight differences. We expect you to model the data presentation, the data interpretation and discussion in class when you present your genes to your group members and to TAs. And so all this data when you come to class should be in your notebook. It should be clear to your audience, either listening to your presentation or reading your notebook, what data helped you make your decision and why. So again, here are the gene calls for two genes from tBrady12. These genes are also present in SheerCon, however, the coordinates are different. So I've included my protocol, along with each protocol step, explanations for how I collected the data, how I analyzed the data, and how the data helped me make decisions about the start for the open reading frame GP4. Towards the end of the document, I present the same gene, GP4, along with the reverse gene, GP42, in the format of the notebook. Please use these entries as models for your own notebook. And lastly, at the bottom of this document is a notebook rubric. And so use this notebook rubric to assess the gene calls that I've made, but also as criteria for creating your own notebook entries. So the procedure I used involved two different procedures, one for determining the most reasonable start for a gene, and the second one was to determine the function of that gene. Now, I want to be clear that what I'm presenting today is only the process for determining the most reasonable start. Eventually, for every single gene that you call, it will include determining the best start for that gene, but also trying to predict a function for that gene if possible. And we will cover how to determine function for a gene in a separate lesson. So the procedure for calling a start involves analyzing coding potential, trying to determine the position of the gene relative to the upstream gene, looking at the frames data, the ribosome binding score, and the length of the open reading frame, examining BLAST data from DNA Master and possibly from NCBI as well. And something that we're not going to do in this lesson, but eventually I'm going to ask you to do, is to look at a program, Pecan, which basically collects all this data for you. And we'll be showing you how to use this tool at a later point. So let's begin with determining the most reasonable start for tBrady12 GP4, or gene product 4. First, examine the information in the notes section for GP4 in the features page to determine if the predicted start was called by Glimmer and GeneMark, or only GeneMark. So I will click on my features page, and you can see that I have the notes already in my notes section. And at the very top of the notes page, I can see that Glimmer called, see, I'm on the wrong gene, GP4, Glimmer called the start at position 783. And because it only mentions Glimmer, I know that that means that Glimmer and GeneMark agreed that the start should be 783. If it said Glimmer and GeneMark, that means that GeneMark chose a different start. If it shows only GeneMark, that means GeneMark chose the start and Glimmer didn't call a gene for this particular position at all. But it is something that you want to note in your annotation whether or not the call was made by Glimmer, Glimmer and GeneMark, or GeneMark only. Next, examine the coding potential in both GeneMark S and GeneMark SMEG for GP4. So I'm going to open up, here I have GeneMark S, I can tell because I have it in my title, but I can also look at my title page. And what I'm going to do is scroll through the pages until I find the position 783, and that's actually on the first page. These are all 6 frames for this particular region in the genome. And here I have boxed in GP4, and right here, this uptick is the 783 start. Now, the 2 things that I want to know about coding potential. 1, does this gene in GeneMark S have coding potential? And it clearly does. It has typical coding potential as well as atypical coding potential. And the second thing that I want to note is whether or not the start in question includes all the coding potential. And sometimes it helps to put a ruler right at that start to check to see whether or not when you go all the way down to the baseline, whether or not it includes all the coding potential. And so 783 includes all the coding potential, which is a really good sign that this is a good candidate for a start. But not only that, it is the only start to include all the coding potential. And so I'm going to want to note that in my notes section, that it includes all the coding potential and is the only start to do so. And so the majority of the time, starts must include all the coding potential, and only rarely do genes break this rule. So the next thing, and I've made screenshots of both GeneMark S, where it includes all the coding potential, but I've also checked GeneMark SMEG, and again, 783 looks like the only start to include all the coding potential. So these are 2 things that are going to go into my notebook. So the next thing I want to determine is where 783 start is located relative to the stop coordinates of the upstream gene, GP3. So to do that, I'm going to go to DNA Master, and I am going to look at GP3, and for GP3 I see that the stop is at 786. Okay, so how do I calculate the overlap or the gap? Well, if the start for GP4 is 783 and the stop for GP3 is 786, then I know there's an overlap, and I've drawn a little model here on how to calculate overlap. And the overlap is in fact 4 base pairs. So this is the magic 4, the fantastic 4. This is ideal. And this is because these genes are in the same operon. Check out the map here at the bottom of DNA Master. You can see genes 1 through 6, and if I zoom in on them a little bit, go back, are likely part of the same operon. And so it makes sense that GP3 and GP4 have this 4 base pair overlap. This is really strong evidence that 783 is very likely the start for GP4. Next, I want to determine what are the other start positions for this particular gene. Are there other reasonable candidates for the start? And what do the ribosome binding site scores or Scheindel-Garneau sequence scores look like for this start 783? To do this, I go to DNA Master. I'm going to make sure I've selected GP4. I'm going to go to DNA, frames. And here comes the frames data for T-Brady12. This is showing all 6 frames for every single position of the genome. First, I'm going to click on ORFs, and now we can see all the genes that Glimmer and GeneMark have predicted in DNA Master. Well, I'd like to focus in and zoom in on GP12, so I'm going to zoom in and then go back to the beginning. Here is GP4, which is what I meant. And in order to look at the ribosome binding sites for each of these different starts, because these are all potential starts for GP12, I'm going to click above all the starts that I want to include in the ribosome binding site analysis. And so this green light highlighted above shows me which starts I have selected here. Go down to the bottom right-hand corner and click on RBS. And I'm going to make this box a little bit more manageable in size here. We don't need it to be that big. And I'm going to scoot it over to the right so I can see everything at the same time. First, I want to make sure that the Shine-Dalgarno scoring matrix is set to Kibler 6. It's possible that yours is set to Kibler 7. We want to be consistent in ribosome binding scores in our class so that when we're comparing ribosome binding sequence scores, we're all using the same scoring system. So make sure this is set to Kibler 6. And now what we have here is a list of all the potential starts for this gene, the sequence upstream of the start, which is where you're going to look for the Shine-Dalgarno sequence, right? And then a scoring system for each of the Shine-Dalgarno sequences. And this score is based on how close is it to the consensus sequence, which you know is AGG, but also it's looking at the distance of the Shine-Dalgarno score from the start codon, which you also know is usually 4 to 9 base pairs upstream of the start codon, with 5 nucleotides upstream of the start codon being ideal. So the way the scoring works is the closer this number is to 0, or essentially the lower, or rather the higher the number is, or maybe the least negative number it is, the better the score. So if you look at all these scores, the highest score is minus 3.5, and the second highest is minus 3.6. This red one with start 783 is our start in question. And so we know that this start has the second highest Shine-Dalgarno sequence score. Now, here's the thing about ribosome binding sequence scores. It's sort of like icing on the cake. We look at it, we consider it, but it is probably, of all the evidence we look at, the least important. So for example, if we have a gene that has a 4 base pair overlap, okay, just as we do here with the start 783, if there's a start with a better Shine-Dalgarno sequence score, such as this TTG start at 906, the fact that this provides us with the longest open reading frame and has a 4 base pair overlap, plus it's the only start to include all the coding potential, all that evidence trumps ribosome binding sequence scores. We really only look at it maybe as a tiebreaker. If there were 2 starts and we didn't know which one was the start and the evidence didn't point more strongly to one or the other, we might go with the one with the best ribosome binding score. But other than that, we kind of record what the ribosome binding sequence score is. And essentially other evidence usually trumps ribosome binding score.